Yo, yo, yo. Can you hear me?
Yes.
One more time. Let's see if it will.
Oh, well now you're really hard to hear.
How about if I talk into the mic?
That's better. Yeah.
Okay. All right. Just gonna see if Eam joins or not.
Well, doesn't she have to? She's just leaving like 10 minutes to go get Sable, right?
Yeah, so I don't know if she's gonna join or not. That's what she was thinking about it.
Where's Courtney?
Well, she usually comes a little bit later. Hey, Eam, because
Hey,
she's got work a little later in the day. Part of why we have these beautiful recordings. All right. In the interest of time, let's go ahead and get started. Dive right in. So today we're covering table creation in SQL, as well as connecting to C Sharp. Okay. Um, and I'm going to start by demoing table creation, and then we'll get into the rest of the slides. So what you'll do is you'll come over here to tables, and you'll right click and do create new table. And you're going to get a window like this. You'll need to name your table up here. Uh, and then, and actually, one thing I learned about this particular, there's different flavors of SQL, and this one I have less experience with. Um, and it likes everything to be lowercase. It saves you from using double quotes a lot. Um, and whether you want to do the underscores and stuff is up to you. Then you won't have any columns here. To add a column, you'll make sure you're on the column tab, and you will right click in the empty space, and it'll give you this option for a new column. And then you'll name your column, and you will select a data type, which we discussed yesterday a bit. And I think what I want is date. My goodness, there's a lot in here. There we go. Date. Okay. And I'm actually going to call this date checked out for my library book table. Okay. And you can see it adds it to the list. Now, there's a number of things that you can specify here. One that I kind of hinted at yesterday but didn't really explain is identity. What identity means is that there can be no duplicate IDs, so you can't have two books with the ID number one, and it will auto number each one for you. So remember how yesterday you had to like go and look and see what people had made? Um, it'll auto increment it to the next number in sequence using an identity. And then we wanted that to not be null. And you know what? I probably want in my library to make sure title is always there. But maybe we want to be a little more flexible with status and who checked it out and the date it was checked out. Okay. Um,
I have a question.
Absolutely. Go
What,
ahead.
what is the naming convention for C sharp for the table name?
Well, this isn't C sharp. This is going to be Postgres.
No, I mean like
And
when working on C sharp, what what is the convention for the name?
so we use different ones, Eam. But
Mm,
I will demo that today when we
okay.
get over to the C sharp side. But in this particular case, this is Postgres database. So we're actually
Mhm.
would be following the Postgres one. Um, I haven't looked up the convention uh, yet. So I think it's snake case, all lowercase, but I'm not 100% certain on that.
Okay.
Yeah. Right now, I'm learning like many different languages at the same time. Uh, for different purposes, and the bouncing around is confusing me, and that's why I've not been consistent in my demos.
Yep.
Yep. Okay. So this is pretty basic. There's other things you can see that we can add in here. We even talked about the benefit of adding foreign keys. I'm not going to require you to learn that because really we're just kind of kissing the surface of database technology with this class. Okay. We're going to be putting in some tools that sort of build the database for us. So I want you to know what a foreign key does. But you're not going to have to do this a whole lot as we move through the end of class. So we're being very light with our touch. So then I can hit File, Save, and that's what actually causes it to execute. So you can see it built this SQL. You don't have to use this user interface, right? You can write SQL and execute it, and there's some really cool things you can do because of that. But it shows it to you, so you can kind of check it, right? Maybe if we had like date created here, oops, wrong button. Okay, so I just executed it. But if we had date created, then you could have it default to like today's date, and then you don't have to code for that. So there's a lot more we can do here with databases, but we're just trying to get it to the point where you can create a table in this database, because for this week's homework, you're going to be doing some basic CRUD operations using your program from last week and this particular database. So you're going to all be in the same database, but your programs are so different. I don't think you're having trouble with two people needing the player character table or whatever. Does that make sense?
Yeah, because we're all sharing the same
Yep.
space, right? On this.
Yep.
Okay.
And so from time to time, you're going to want to come into here and hit refresh, because like I said, other students may have added tables, and you'll want to see what's there and check it and that kind of thing. So that is table creation in Postgres in 5 minutes or less. Let's dive into the rest of the lecture. So to recap, we've been talking a lot about C# and object-oriented programming in this boot camp. We've talked about the single responsibility principle. We've built classes in C# and given them fields and properties and constructors and methods. Yesterday, we introduced SQL as a second language, which is an interpreted language, and we like it because it does a really good job of storing data efficiently. And then we also did create, read, update, delete operations within that database. So today we're going to take a look at Mike's syntax, and we're going to make some tables manually in dbeaver, which we just did. We're going to connect a C# app to the Postgres database. And we're going to run CRUD operations from within C# as opposed to running it in dbeaver. And that's going to help us tie our SQL back to object-oriented programming concepts. Why are we creating the tables manually first, even though we're going to introduce this tool later that does it automatically? It's because I want you to understand what the tools are doing for you, right? And I want you to see, like, I don't want it to be magical, right? I want you to be able to, if you needed to debug something, open up dbeaver, find your database table, query it, and figure out what's going on with the data. You do have to debug, like, a lot of times if you're having a problem, sometimes it's code, sometimes it's data that's bad, and so being able to search your database for bad data is an important skill set. This also ties in that typically when building an enterprise application, we will decide on our data structures first, and then we fine tune our behavior second. There's a little bit of back and forth between there, but a lot of times we want to build at least the big broad strokes of our data structures before we start getting into behavior. Oh, I just showed you that. Okay, there's a slide on it. So primary key choice, what I mean by that is, are we doing an integer or are we doing a GUID for this week, I want you to use integers. We'll probably be switching into GWIDs in a coming up week. Whether or not it should be nullable, you can think of that as being very similar to your constructor. Okay. Foreign keys for relationships. So if I wanted to add a foreign key, I can click here and do new foreign key. And then I said students can check out books. So I'm going to have the student. I haven't done one in here yet. Let's see if I can figure it out quickly. Yeah, that's a great name. This is kind of common. And okay. Oh, the reference. My bad. I see. It's asking me which table it's going to, which is going to be students. Okay. Now we can specify that the library books checked out by column is an integer that references the student ID. And what that means is that I can't put a student ID into the checked out by column that doesn't exist within my students table here. And then I have to save that. It's going to tell me that we're going to change the table by making this constraint, and I'll hit execute. Okay.
John, you must go.
Yeah, I have to go.
Okay.
Okay.
We'll have the recording for you, Ian, and if you get stuck or have questions, just let me know, okay?
Okay, I'll watch it. Okay.
All right.
Bye.
Thank you. Bye. So right now, just be consistent in your naming. We get later into things, we will give you some rules for naming. Okay. So you're used to seeing databases in dbeaver. How in the heck are we going to teach C# to talk to Postgres? TCP, substitute that for being a network in your mind. Well, we're going to have...
Wait. TCP?
Yeah.
Is it TCP reports?
Those were TPS reports.
Oh, okay.
Yeah.
I almost had an aneurysm there.
We're going to use a third-party package for sending SQL that we write in C# over to the database. In order for that to work, that package is going to need to know the connection string, which is a set of configuration statements, address, and credentials. Yeah, so there's no magic in it. The same queries you were writing yesterday are going to work in C#. Okay. And because the database is a separate system, your database can go down and your app can still be running, and vice versa. Your app could crash and your database could still be up and fine. So downtime between them is separated.
So
you're going to see a connection string. Go ahead.
Can you? I'm sorry. Can you go back one?
Yeah.
So C#. Okay, so if I'm writing something in SQL, do I have to know that I'm going to be using C#? Are there things that I can do or write that won't work in C#?
So any programming language is going to be, most modern programming languages, any is such a tough word, is going to be able to talk to that SQL database. And it's not uncommon for multiple different technologies to use the same database. So, for example, your bank, okay? They publish an app. That app might be hitting up the bank's database at the same time that the bank's web page is, and at the same time that the program that the teller uses is hitting it up. And those can be in completely separate languages.
Okay, so there's nothing
the SQL will be the same, but what you're going to see is that there are third-party libraries that we're going to use that are going to turn more object-oriented code into SQL for you. Okay.
Okay.
Okay. So in the connection string, which you're going to see pretty soon here, there's a host and port, there's a database name, there's a username and password. Um, I probably should remove that bullet. I don't know that I like that one. Uh, so what happens is we're going to use some C# to create a connection to the Postgres database. We're going to write a command. We're going to execute that command. If there are results, then we're going to read those results, and then we're going to close the connection. And all your same operations are going to work just fine. And this is the wrong way to write your queries, but it's a great place to start. Okay. This can create some security concerns in production, but I'm trying to tie it into yesterday, right? So we're going to start with this, and then we're going to get into using some of the tools to make our code more secure. Does that make sense?
Yeah, we're learning the
Okay.
basics before we get into the advanced stuff.
Yep. Okay. So, yep. And select, remember, it can return one row or many rows. So you're going to see examples of that in the code that I prepared. Uh, we're going to be doing inserts, and you're going to do your own update today. I did not provide an update example because I think based on yesterday and this lecture, you're going to be able to do that no problem. And then at the end of the day, I will give you some code for a more object-oriented approach. And that's what we're working towards on Fridays, is kind of doing this object-oriented communication with the database. So we're getting there. We talked about delete being permanent yesterday.
And the soft
Where
delete, yeah.
clause definitely want to be mandatory. You can delete your whole table if you're not careful. Uh, and we talked about soft delete and hard delete, but we're still not ready to implement that yet. For now, we're going to do hard deletes. Okay. Common beginner mistakes. You select the wrong database. I've only given you access to one, so you don't have to worry about that. Not having permissions in your connection string. If you're copying off the internet, most people are not going to put their permissions into that connection string. So you do have to kind of know how to insert that, and we'll be showing you. Forgetting your where clause, using the wrong where clause, mixing up, syntax and that kind of thing.
Yeah.
Yeah.
That was my big one yesterday.
Yeah. So the big thing I want you guys to understand is C sharps. They are the program you're building there. That's like short-term memory, right? We're not writing a whole bunch of data somewhere. As soon as you turn it off and turn it back on, you got to start over again. Databases are all about storing data forever. So these two both have an important job. This doesn't have a very nice front end. This is where we create our front end. SQL is how we translate our class objects into tables that the database stores. And CRUD is how we manage object lifecycle. Create, read, update, delete more or less handles everything we could want for an object. So a lot of today is going to be actually showing you code. So there are some things that we have to do to get started. I got to show you how to add a third-party package into your project. The one we're going to add is called npgsql. And I'm going to show you the NuGet package manager and how to add it. Really easy. We're going to create what's called a data access layer class. DAL is a very common acronym across different programming languages to indicate areas of code where we're talking to the database. We're going to write some really bad methods and watch them run, and then I'm going to show you a better way of doing it. After class today, you're going to get all the code so that you have a sample of it, and I want you to put it into a fresh project separate from your existing stuff. And I want you to add an update method to your data access layer, and I also want you to go into dbeaver and create a table in that engineering bootcamp database that is towards your goals for this week. So like Mike, it'd probably be your character table.
Yeah.
Um, and then add a. You can do the upsert to the temporary project, not the big one. Um, we can table that a little bit. So let's bring the screen over here and take a look. So let's make it big. And oh, I'm on yours. My bad. Like, this looks different. Okay. Oh, we're gonna look at your code first. Sorry. Okay. So when you ran this all together, this semicolon was not there, and I think this is a case where it requires both. Um, if you run this instead of highlighting one, right? If you just have nothing highlighted, it's going to run both queries, right? And I think PostgreSQL would like the semicolon to alert it when query 1 is done and query 2 is running, because they're both happening together. I took this code without any changes, ran it, and then I highlighted this and ran it with the D. That's important, right? And both of your code ran just fine. Does that make sense?
I'm sorry. No. Where's the semicolon? Oh, up here.
Right there. Yeah.
Oh, okay. Because I was
So
definitely
yeah,
afraid of touching
I'm
that.
glad that we well no, and people asked about semicolon yesterday, and it's so often forgiving. It was hard to understand a case where it was really needed. And I think it's needed here because we're going from a select statement to a different kind of query. But it really does depend on how they wrote the Postgres language. I use a lot of Microsoft SQL Server, and it's very, very rarely do I need a semicolon, you know, um, which is why I was trying to avoid the topic yesterday.
Got it. So
Okay,
the way I did it's functionally correct.
correct. It's because you
Okay.
ran two queries at the same time, and the authors of the Postgres language wanted uh, a semicolon between two queries.
Well, it didn't make sense to me to run them individually. It because if I ran this, how does it know to put it on this table? If I ran this, that just generates the table, right?
Mm, okay, no, no.
Okay.
The table exists. The table is over here, and the table never ceases to exist. Unlike C sharp, the table is always there. It's right here. Okay, got
Mm.
that for a second. So all this does is
I know what that
tell.
does. What does this do?
What does this do?
Yeah, what does that do?
This creates a view. It takes a subset of the data and makes it visible to you.
So it's just basically this is formatting the data for me to look at.
Correct. That's a great way to look at it.
Okay, and then this is okay, and then I created this to tell it I want this student in this class. Good.
Right.
Okay. All right. I misunderstood completely
Yeah.
what this was up
The
here in.
table is the table. This is a view of the table. That is a great analogy.
Yeah, this is how I want it formatted so I can look at it.
Yep.
Okay. Okay. All right.
Okay.
I'm on track.
All right. Okay. All right. Now let's flip over and take a look at the project that I built for you guys. Remember, you're getting all this source code. So I think between the video and the code, you're going to be in great shape. Okay. Um, all right. So first off, in my I did put a little bit of code into my program. I tried to keep this really, really simple for you guys. You know,
Thank you.
so we'll walk through this in just a second here and see it. Now, when you first start it, well, okay, let's look over here. So one thing that I did, where in that database, we already had classes, students, and now I have the library books. You can see where there's all these tables and good separation of responsibility, right? I would probably want to have a different class for how I access each table and do my CRUD operations on that table. So knowing that I'm probably going to end up with a lot of them if I choose to continue this program, I made a folder to hold all my data access layer work separate from the rest of the program. Does that make sense?
Uh,
And the way that I did that is I right clicked on, oh my gosh, all that stuff. I right clicked on the project and I hit add new folder, right?
okay.
And so you could imagine, like, if we're building a big application, right? One of our folders might be user interface. And the user interface and the data access layer, um, we'll explain why. I think it's like a week away. We're going to explain why, but generally we want to keep those things separate. So this is a little bit of looking ahead, okay? And all the folder does is keep my code organized. It doesn't do
Right.
anything beyond that. Yeah,
Right.
yeah. So okay, so I made a folder. I called it data access layer, and then inside there, I made a class called data access layer students. Now, inside here, I did put my model class right here, which should look very familiar from last week, right?
Hmm.
Normally, this would not be in here, but in order to keep the sample program really lightweight, I put them in the same folder. Okay, but it's usually good to keep my model separate from my data access layer. Okay. Um, Now, uh, we needed, so this is my data access layer for students. So inside here, I've got a create method, a delete method, a get method, and a get all method, right? And so the update is missing, right? Um, And I mentioned in the lecture that connection strings are important. Different SQL technologies are going to have different connection strings. So this one works in Postgres. It is different than what do you call it? A different, like a Microsoft SQL server will have a different set of things that have to go into connection string. So we're specifying where does the server lives. It happens to live on this IP address. What port do I use to connect to it? What's the name of the database? So this should look familiar. The name of the database is going to tie in with, okay, I guess I didn't load it in there. Here we go. With here is the name of the database. So you can see the name of the database server. There's my host and port, right? And then here's the name of my database. And I'm going to give you the connection string, but so that I don't display the password, we're going to do that later. It'll be in the code that you guys get. Okay. But the last two things are the username and the password. Okay. And this is just a string. You see, it's getting saved right there. I kind of want to protect it. Connection strings are one of those things that hackers love to get a hold of. So as much as we can, we want to protect it. And this is not the right way to store your connection string, but it's a good way to get started for right now. And as we grow in skills, we can add complexity and put this in a more safe place. Does it make sense?
Well, yeah, we're learning coding, not security yet.
Yeah, exactly. Uh, okay, so we'll collapse our constructor there. So just one constructor, and hopefully this looks pretty simple. This is very similar to what you did yesterday, right? We're going to create a string that's going to hold some SQL because remember, it's all just files, right? Uh, and we're going to do insert into the students table. I'm going to have my student ID, my first name, last name, gender, and grade, just like we did yesterday, right? And
Mm-hmm.
then I'm going to have values underneath it. You'll notice I end the parentheses, but I don't put a semicolon. I do a plus, and then I do another exclamation point, or sorry, dollar sign, because I want to be able to insert the values, and then I continue, right? Now, if you remember from yesterday, hopefully I still have that code up. Oh, still the wrong database. Hang on. Yes. Okay. Okay. Yep. So here's our examples from yesterday. So remember how strings had to have that single quote, right? You'll see
Yeah.
I've placed the single quote, gosh, around my strings. I did not place it around student ID and grade because those are integers. Does that make sense?
Yeah. Because yeah.
Okay. Uh, then, following what was in the slide, this is how we create a connection. Okay. Uh, and we want the connection to auto close. So you're getting a new command here called using, and using in in the more modern versions, you will not see these braces, but I want you to understand that the braces, even though they're removed visibly, they still exist. Okay, and and so what I'm saying is that at the end of when the code moves past this brace, then close the connection. Okay, if it throws an error, it's going to close the connection because it has to pass by that brace to exit the method, right? That's really important because you can imagine a database server, right? And it's getting pinged 1,000 times a second. If the connections get left open, eventually it won't have anywhere left to uh, for somebody to connect to. Does that make sense?
So there's only so much access that's allowed to a database.
Correct. And this is true for a lot of things in computers, right? Like even though a computer can accept tens of thousands of connections, right? It can't accept millions of connections. That's why you got to have multiple servers sometimes, you know. Everything has a limit, and this is one of the ways that it we can do that. It was auto close that
You're
connection so they don't get left open.
yeah. You're maximizing your ability, like you're making the best of what
Yeah.
you got.
Yep. Correct. So this creates a place for the connection to be, but you may not want to open it right away. In our case, we do, but sometimes we just leave it there for a while. Okay. Um, so this line actually calls the database using your connection string, which you supplied right here, you know, to establish the connection. Okay. And then it's implicitly closed right here. Then we need to create a command, and think of a command as being like this sheet that we're looking at. Okay. And normally you just put one SQL statement into your command, but it wouldn't surprise me if you could do a whole bunch. Uh, and there's probably use cases for that. In fact, I can think of a couple already. And it also wants you to auto close your command, um, because the command is tied to the connection, right? And so the connection doesn't want to have an infinite. It doesn't really know when you're done with the command, and it's leaving a space for that in memory. So by closing commands, we can more effectively use our connection. Uh, and so then I'm going to say the command's text, which is just a string, takes our SQL that we defined right here, right? And then it executes it. Scalar means return one value. And because on an insert we don't really get anything back, that's fine. So I get the result, and I just went ahead and wrote it to show you that we're not getting anything back. Okay, and we'll drop a breakpoint right here so we can view that when we get into executing it. Then I also built a delete. So you can see it's very similar. I'm not expecting anything back, right? Uh, and and then we can drop a breakpoint right there. Okay, and then I created a get. I want to be able to store and get data back. So here's my select SQL, right? And then I've got my connection and my command, but now we're getting into something a bit different here. So this execute reader is different than execute scalar. We're expecting more data coming back now, right? Now in this particular query, we are going to get all instances of students that have a particular ID. Since that's unique, I can safely assume that I'm just getting one. And I wanted you to see how the results come back. These ones are going to return null, but this gives us more information. So I have a couple of spaces here to kind of show some things. And then, remember before I said you're going to like that constructor in the future? Here's where it comes in handy. So those results do not return a student class. Your data access layer doesn't know anything about that. You have to manually assign your result values into the student. And I decided to do it in one line of code using that big constructor, just like what you had for your character class. Does that make sense?
Yeah.
Okay. And then I'm going to return that student back to the calling program. Finally, to show you what it could look like getting all students or all pieces of equipment or all spells, you know, I wrote it without the where clause, right? And then in my reader, I did a while loop. So as long as there's rows, it's going to keep going. And you can crash your system doing this. Not on our teeny tiny little database, but do it on a much larger one. You can end up with problems. And so we make those students and we add them to result, which in this case is a list of students, right? And then that gets returned. So this is not a void. This is not a void, right? Because I'm expecting some data back. So now when I go look at program, hopefully this makes more sense. So I created a student, okay? And I created my data access layer. And the first thing I did, because I've hard coded my ID and I want to do a demo, right? And I also want to test to make sure my code worked before I demoed it. So the first thing I'm going to do is if there's already a Natalia, we're going to delete her. Okay. And that way I can add her back in. Now, obviously, in real life, we would probably do something more like an identity so that we know the ID is always new, or we would get the next ID before going in and creating it. But this is just for a demo, and you guys are smart enough to solve those problems as we move through this. And if not, I'll give you a hand. So then I want to get a student. Now, the reason this is called student 2 is because this is all in one block of code, and student is up here. And this is creating a new instance of it at this moment. Even if it happens to be getting Natalia, it's a different instance of Natalia than before. So I called it student 2. If I wanted to overwrite it, I could overwrite it like this. Okay. But I wanted to express that it doesn't intuitively use the same data. You have to tell it you want it to be the same instance. Okay. And if there's anything different in the database than over here, you're going to get what's in the database and lose that information that was over here. Then I didn't really show you guys read key, but that's how you get this press any key thing that you've seen ubiquitously. So instead of having to press something and then hit enter, you can press any key on the keyboard and it'll then continue. Because if you remember, our database, I think, had like 30 students and you guys went and added a bunch. And so I wanted a little separation there. So let's now run our program and see what happens. Ready?
I think so.
Okay, here we go. All right. Remember, I dropped some breakpoints in, so it's going to be jumping to that. Okay. So remember, the first thing I did in program was I said delete it, right? And I wanted to show you that when scalar is returned, because delete doesn't return anything, scalar just has null. And so we're going to write null to the console, which is hard to see, which is why I wanted the breakpoint. Then, after we're going to exit this, it's going to run create. And in create, when an insert statement runs, it doesn't return anything automatically. And so, sorry, trying to be helpful. Execute scalar returns null. There's nothing for me to print. And you can test this in SQL, right? You can take these queries and drop them into dbeaver and play around with them and get different results. And a lot of times it's faster for me to write these queries over in the SQL editor, get them exactly where I want them, and then bring them into here and do the final changing of parameters and things like that to something C# friendly, right? Now, in this case, we're doing execute reader, and select is going to return something. So I wanted you to see how complicated result is. So you can see it's, let's look at locals. That's probably a better way to demo this. So this is a data reader object, MPG SQL data reader. And it's got all kinds of information here. These are all fields and properties that you can access. And if you click on result view, it's going to tell you, oh, that's interesting. I would have expected this to have a row. Okay, under statements, it's stored that command text as a statement. Okay, and let's take a look. So if I were to just go and write my results, let's go take a look at this now. So remember, toString is what gets edited if you don't create an override for toString. And so it's telling you the type. I basically duplicated on purpose to kind of illustrate that. It's a complex object structure with all kinds of stuff in it, you know? And and then I can do, oh, you know why I didn't see the data is because it has this read function. I might have messed it up a little bit. I think with all the stopping, it probably closed. Let's remove the breakpoint and rerun the program. Do I have these other breakpoints in play? Yeah, we don't need these anymore. Remember, it's two separate pieces of software, so it's not going to hang on forever. Okay, so there. It saw Natalia, and then over here in program, I told it to write line student 2, and in my student class, I took some time to override toString and build a nice way to read that student record, which is what you're seeing right here. And I got a little fancy with it. You guys can take a look at that later and see what I did. Okay. Now, I'm going to press any key, and boom, it just printed off everybody in the whole school. I didn't specify an order, so it's whatever order the database thought. As database optimization changes, this order can change. So it's, if order matters, you're always going to want to put an order by in your select statements. And you can see there's Natalia, most recent entry. I'm in here too now. Does that make sense?
Yes.
Okay. All right. So the thing I didn't show you how to do is, if you took all this code and you made your own project and you don't do what I'm about to show you, it's going to tell you it doesn't know what NPG-SQL is. And this is going to get a squiggly little line saying, I don't know what the heck of this is. And you're like, well, Jonathan told me in there and I saw it work for him. Why is it not working for me? This is where it gets into package references. This is something that we have to learn. Okay. So over here in Solution Explorer, I have all my code, but I also have this little folder here called dependencies. And this is where code that our code needs is being stored. Okay. So what that means is if I've probably you've seen some of my code, and I had like multiple projects in here and all kinds of fancy stuff going on. There's different ways of showing code that our software is dependent upon running. When I keep saying package, I'm referring to this guy, which is called packages. And if I right click on dependent, you won't have this until you add a package. And inside of it, you can see we're using NPG SQL version 10. Okay. So when you first create your new project for your work today, this won't be there. You're going to right click on dependencies and do manage NuGet packages. NuGet is like an internet based repository where all these things get stored. Okay. And then you're going to be on browse. It'll probably default to installed. So come over to browse, type in npg SQL, just like I have here. Okay. And you'll see this come up as the first result. You will click on it and you will hit right here. It'll say install. For me, since it's already installed, I'm getting the update on install options. But for you guys, you'll just install it. And that's it. Once that's done, then the software, you might have to do a build. That does happen sometimes. But after that, the software will know that this is okay. And once it knows that this is okay, then it'll resolve this guy right here. Does that make sense?
Yeah, but why? So why do we need that? That package is what allows us to talk to SQL.
To the Postgres database specifically.
Oh,
Other SQL
specific. Okay.
libraries will have a different package for doing that. Okay.
So when we have our own, no, because this our stuff is going to be inside of the Postgres, right?
For this week, we're using Postgres. Okay. Later
Okay,
on, we're gonna probably switch database technologies, but there's very little difference, and this is a slightly easier one for me for teaching this class. Okay.
got it.
Yeah. Now the reason that you need it, because I heard that, and it's a great question, is remember how I talked about this thing making a connection and connecting to a TCP port and all that stuff, right?
Mm-hmm. Mm-hmm.
Uh, Without a package, you would have to write all that code. It's a lot. I mean, that's really like the backbone of the internet is TCP traffic, you know. So the complexity on it is huge, and it's nice to be able to take and work with a certain level of abstraction. Does that
What
make
does that
sense?
look? What's the TCP code look like?
Um,
Doesn't matter.
so when you want to talk to another computer, you're going to have to do a couple of things. I'm going to try and keep this to a minimum of instead of showing you code, I'm going to kind of talk about how that works, okay? So I got a computer over here and a computer over here, and they want to talk to each other, right?
Mm-hmm.
Um, Now, traffic always has a direction. We're going to just call this A, and we're going to call this B, okay? And and first off, I have to know how to get from here to here, right? Like the internet has all that, you've seen these diagrams, right, of like nodes and lines and all that,
Right.
right?
Right. Right.
Okay. And so the first thing is I have to know where this thing is. Okay. That means going and talking to an internet DNS server or a local DNS server and figuring out where it is. Okay. And if there's multiple hops, right? Like if there's probably several nodes between Hawaii and California, they might be this my computer talking to this DNS server and then talking to that one and then talking to that one before finally figuring out exactly how to get down which fiber optic line or piece of cable or satellite to get to you. Okay. Then I got to know your port. Your computer has all these ports. What a firewall does is it opens and closes ports, right? And so uh if I go to like a really common one is port 80, right? A lot of ports have a specific function. Port 80 is for web pages. So my servers back there that are hosting web pages, Port 80 and port 443, which is secure web pages, are open so that computers can talk to that traffic,
Mhm.
and or can go and get the web pages. If the firewall closes those ports, you're going to get a 404 error, which is saying, hey, I took it as far as I could, and then someone told me no. You so that has to be open over here. In this case, Postgres is talking on 5432. So what's going to happen is I'm going to take that data, decompose it down into packets, send my authentication along whatever route I got from all here, right, to this computer. Hope this thing is going to reassemble the packets into a request. It's going to decide if it's going to allow that request to come through or not. If the syntax is wrong, if I've structured my request in a way that it doesn't expect, right, it's going to send an error back. Assuming that it does like my structure, it'll then go off and run that SQL, reformat it back into the response format, send that back across the internet, possibly a different route until it gets to me, and then it's gonna have to get reassembled on my side back into something usable. And so that Postgres was an NPG SQL package that we pulled in is doing all that heavy lifting for us. So even though this is a lot more complicated than what you're going to have to do in the near future, this is a nice way to not have to rebuild the internet. Does that make sense?
Yeah.
Okay, cool. Then and so I did promise that I would show you kind of an example of where this is going, and I'm going to put this in. I didn't want this in the sample program yet, but hopefully we can kind of see it down here. Um, so uh, you'll see here in my string, one of the things that hackers will do is they'll do what's called a SQL injection attack, which means that they, when we go through to do our insert statement, like right here, right, they'll be like, hey, you know what? Instead of putting the first name in there, I'm going to do select star from the user table and download all the users and all their passwords, and trick it. And this has been done many times. So we actually don't write our SQL code this way, but this is close to what you did yesterday. So there's a small abstraction on top of it. Here it is, where we can do this at thing, and then we take our command object. Sorry, we can do, was it connection dot new command? I think it was, right? And this is the big piece I wanted you to pull out of this, is you do these parameters. So you say the name one is equal to student name. Don't worry about, well, you should have that, but I want to keep it simple for now. Okay. Um, we don't have, this is a problem. We don't have name. We have first name. We don't have email. I wanted you to see this concept of where we're going to let this command object um, uh, replace the values for us. And there's code inside of here to protect against SQL injection. Does that make sense?
So, well, but how? So
I got,
how does it protect?
okay, so what it's going to do is it's going to look at, it understands, because we're just saying we're adding these parameters, right? That student name should not have a bunch of select this from this place or delete this, or create a new user, and the different ways that people will use SQL injection to compromise the system.
Oh, I see.
It's
Okay,
looking for that. Yeah, it's looking for that and applying those rules for you.
got it. So that's just
Okay.
a way to communicate to it. Don't, yeah, don't let them do. If you see it, just
Right.
ignore it, or
The
fail.
end
Right.
result, right. The end result is it's gonna send SQL like this to the database server, which is just like the SQL that you were writing yesterday, right? But it's going to do some of it for you and check it and make sure it's safe before it does it.
Right.
Okay. Okay. It's also good for you to do your own checks because this is kind of a messy place for it. Like, if we were building a web-based UI, we would be putting checks on these kind of things way up at the front end of the user interface instead of way down here at the back end when we're about to execute a command. But you can never have too much security, you know?
Yeah.
Yeah.
Because there's always a way
Okay.
around. There's always someone's
Right.
always figuring something
Right.
out.
Yeah. So, why don't I stop the demo and then upload the code, and then if you need to, we can get on Discord and talk through what we're doing. Does that make sense? Like if you get stuck, if you're looking at this code and you're not sure where to start for completing, oh, wrong window. So I should recap. So what I'm looking for you to do next is copy that code and get comfortable with it, read through it, right? Add an update method because that's the one I skipped. So that's taking what you learned about doing updates from yesterday and wrapping it up in a method. Create a table in the database, just like I showed you in doing it over here by doing the create table, right?
In the library book, yeah.
Yep. And then take it one step further. Pick something. You don't have to do it in your project, your D&D project or anything, but do something in there to just take it one step farther so you're not just copying and pasting. Does that make sense?
Yeah, you want me to play with it and figure some new stuff out.
Yeah. Get stuck, and then I'll come get you unstuck.
Well, I'm pretty good at that.
Yeah.
Really good at
So
that.
yeah. Okay. Awesome.
Now,
So I will get that all uploaded for you. Yeah, go ahead. I want to stop.
okay.
Let's hold the Discord because I want to get the video up as soon as possible
Yeah.
for
Yeah.
Yeem and Courtney. Okay.
No,
All right.
that's fine. Yeah. Okay.